Welcome to Week 2, Chapter 2. There'll be several presentations for Week 2 because Week 2 covers Chapters 2, 3, and 4. So let's get started. Chapter 2 basically consists of life's chemical basis. So throughout this chapter, we're going to discuss the chemistry of life. In general, what is chemistry and how is life built upon these chemical molecules? So our first slide here is showing you the structure of an atom. And this is a really simplistic view of an atom. In all reality, the electrons of an atom are constantly in motion around the protons and the neutrons, which are centrally located in the nucleus. Here it's a very static picture showing electrons located in what appears to be an orbit. Again, in reality, electrons don't orbit. They do travel outside of the nucleus, but they're constantly in motion around specific types of pathways. So in this static view of an atom, we see protons represented by a rosy color, and those are positively charged subatomic particles. We see neutrons represented by a green color, and then we see electrons represented by an orange color. The protons and the neutrons make up the central portion of the atom called the nucleus, not to be confused with the nucleus of a cell, which we'll discuss in Chapter 4. And then the electrons move in somewhat of a pathway, but it's not as clear as like planets orbiting the sun. The electrons are negatively charged and they move outside of the nucleus. And it is actually the electrons that enable atoms to form bonds, which we'll discuss in a few minutes. This is an image of the periodic table, and the periodic table is basically an arrangement of all of the elements, and it is constantly changing as new elements are discovered. And the arrangement of these elements is based upon a lot of different features or characteristics that atoms have. So when we talk about atoms and atoms' ability to interact and form molecules, think back to what we discussed with Week 1, we're concentrating on, can atoms interact? And atoms want to interact with other atoms if their outer shell is not complete. Similar to this picture, which is showing you at the top one woman on a patio that can hold two people. So there is a vacancy there. Whereas on the lower patio, there are two people on that patio, so there is no vacancy. So if in an atom the outer parameter called a shell is not complete, that means there is a vacancy, and the atom will seek other atoms to either share electrons or transfer electrons. And that's what forms our bonds. So let's take this to the structure of atoms and how they interact. So in this picture, we see the hydrogen atom, and the hydrogen atom has one proton and one electron. And electrons fill outside of the nucleus of atoms in what are called shells. So kind of think of them as nesting dolls, where you have a doll of a smaller size inside of a larger size doll inside of a larger size doll, and so forth. As the atom increases in the number of electrons that it has, it's going to increase the shells. So since hydrogen only has one electron, it's only going to have one shell. Same thing with helium. Helium has two electrons, so it's only going to have one shell. And if you notice, the first shell is very small. Think of it kind of three-dimensionally in a volume. And if you compare a golf ball to a baseball and then a baseball to a basketball, the golf ball is much smaller, so it has a smaller volume. So in essence, it can hold less electrons. And the first shell is actually stable with two electrons. It can't hold any more than two electrons. So the hydrogen atom, because it only has one electron, it will seek to bond with something to fulfill that shell, which would be another electron. Since helium already has 2 electrons, it's part of what we call the noble gases. It's balanced, it's stable, and it's not seeking to bond with anything. If we look at carbon, oxygen, and neon, all of these atoms have 2 electrons on the first shell, so their first shell is complete, but then they have additional electrons on the second shell. Carbon has 4, oxygen has 6, and neon has 8. Since carbon's second shell only has 4 electrons, and this shell can hold and be stable at 8 electrons, it's going to want to bind with other atoms so that it can gain or share 4 more electrons. Oxygen has 6 electrons on its second shell, and because it has 6, it needs 2 more to become stable with 8. And neon, having 8 in its second shell, is considered to be stable, and it is a noble gas, and it will not react. So you might ask, well, why does the second shell now become stable with 8, whereas the first shell was stable with 2? Remember the analogy of the golf ball and the softball and then a basketball. So let's say we're now into the softball or baseball size. So those are larger than the golf ball, so they can hold more electrons in that shell, and they are stable at 8. Okay, now we're looking at atoms which have even more electrons, sodium having 11, chlorine having 17, and argon having 18. So since the first shell can only hold 2 and the second shell can only hold 8, we need to go to a third shell with sodium, being that sodium has 11 electrons. 10 will be on the first 2 shells, so now the third shell has 1. Chlorine having 17 electrons, 10 being on shells 1 and 2, is going to now have 7 on the third shell. And argon, having 18 electrons, is going to have 2 electrons on the first shell, 8 on the second, and 8 on the third. Argon is now complete. It's stable with those 8 electrons in that third shell. Chlorine has 7 electrons on its second shell, so it can hold 1 more. And sodium only has 1 electron on that third shell. So for it to be stable, it either needs to lose that 1 electron and drop down to the second shell being stable, or gain 7. Now the third shell is larger in volume than the second, so you would think, well, it can hold more than 8 electrons. And you'd be right, it can. But it is stable at 8 electrons. So argon is considered to be a noble gas, being stable with 8 electrons and therefore not reactive. Chlorine is reactive and is going to need 1 more electron. Sodium is reactive and is going to need 7 more electrons, or it will lose 1 electron. How does an atom decide whether it's going to gain or lose electrons or share them? It's all really based upon the energy of those electrons and what is the most energetic or energy efficient way for that atom to bond.